Let's see how we can use SQL triggers to change the content of a view based on multiple tables. It's very often we use a view based on multi-tables to present data in a more meaningful and intuitive way. There are scenarios in which we need to change the content of the view. But if a view is based on multiple tables, we will not be able to use insert, update, or delete to change the content of the view directly. Instead, we can develop SQL triggers to work around this limitation. When the insert, update, or delete command is running, SQL Server maintains two memory resident virtual tables, inserted and deleted. When the insert command is running, the data that is being inserted is kept in the inserted table. When the delete command is running, the data that is being deleted is kept in the deleted table. When the update command is running, the old data is kept in the deleted table. The new data is kept in the inserted table. When we develop SQL triggers, we will make use of these two memory resident virtual tables, inserted and deleted. Let's look at some code. We are going to create a demo database for our discussions. Create it. Switch to the new database. Now we want to create several tables. We will have a very simple order processing system. We will have a customers table, an orders table, an order items table, and a products table. A customer may have one or more orders. An order may have one or more items. Let's create the tables. Create them. Put some data in the tables. Let's create a view based on these tables. We can see the view will be based on orders, order items, and products. Create the view. Now let's try to insert some data through the view. We couldn't do it. We got an error because the view is based on multiple tables. Now let's create some triggers so that we can change the content of the view. First of all, we want to create a trigger to allow us to insert data through the view. Create trigger, give it a name. This trigger is based on the view. Instead of insert means when the insert command is issued against the view, this trigger will run. In the trigger, we use the inserted table. We do an inner join to orders just to make sure that if we insert an item for an order, the order exists. In this example, if an order does not exist, an item will not be inserted. We will not create a new order, but we can enhance the code to insert a new order. Let's create this insert trigger. I didn't highlight the right block of code. Let's redo it. The trigger was successfully created. Now let's try to insert data through the view again. It worked. The trigger did the magic. The trick is the trigger inserted new data into a table at a time. Now let's create a trigger so that we can delete data through the view. Create trigger, give it a name. This trigger is based on the view. Instead of delete means when the delete command is issued against the view, this trigger will run. In the trigger, we use the deleted virtual table. We will first delete order items for the requested order. Next, we want to check whether there is any item remains in an order. If there is no item left in an order, we want to delete the order as well. We do a left join between orders and order items. We check the order ID of the order items table. If it's null, we know that there is no item left in the order, and the order can be deleted as well. Let's create this delete trigger. Now, let's try to delete some data through the view. It worked. Another delete. It worked. The trigger did the magic. The trick is that the trigger deletes data from the underlying tables one at a time, one table at a time, until all of the requested data has been deleted from the underlying tables. This demonstrated how we can use triggers to work around the limitation and to change the content of a view based on multiple tables. Lastly, let's do some housekeeping. Let's delete the demo database. This is the end of our discussions.